This presentation was prepared as a part of HAP 671 course on healthcare databases taught by Farag Alemi, PhD at George Mason University, Department of Health Administration and Policy. A poorly designed database is inconsistent while adding, deleting, and updating. Database normalization is organizing non-structured data into structured data, which improves integrity of the data. Normalization usually involves dividing a database into two or more tables and defining relationships between the tables. Non-normalized tables generally means that the same data is stored in more than one location. The purpose of the normalization is to increase the efficiency by improving integrity and decreasing complexity of the data. Data redundancy happens when the same piece of data is held in two separated places. To allow users access to data without knowing its location. Normalization helps in removing undesirable database anomalies. Data maintenance becomes tedious, so normalization is useful. Requirements for effective database. Rule 1. Each table should correspond to a single entity. Rule 2. Rows in the table should correspond to individual occurrences of the entity. Rule 3. Primary key should uniquely identify the individual occurrences of the entity or relationship. Rule 4. Non-key fields should be facts identified the primary key. Rule 5. Each fact should be presented only once in the database. Normal forms. Applying a set of formal criteria and rules to a database is called normalization. There are different types of normal forms. In this video, we are going to briefly discuss about first normal form, second normal form, and third normal form. First normal form. This is the step 1 of the normalization process. Every table in database should be at least follow first normal form while creating and storing data. The 4 rules to be followed are: each column must contain single value but not multiple values. 2. In each column, the values should be of same kind. 3. Each column to have a unique name. 4. Order in which we store doesn't matter. Here is a table of student data which violates first normal form. The solution for this is all columns are unique. We didn't mix the different types of data in our columns. Each column contains atomic values. Few values are getting repeated, but values for subject column is atomic, and hence it is in the first normal form. Second normal form. The table should be in the first normal form. Should not have partial dependencies. In this table, the student ID acts as the primary key and which is also unique. The student ID column acts as a primary key to fetch information from this table even though with the same student names. So the primary key might be a single column or group of columns to uniquely identify each row in a table. Here is an example of Marks table. In this table called Marks table, the primary key is Marks ID. But student ID and the column ID makes more meaningful primary key. For example, in order to know the marks of student ID 234, it's impossible as we don't know for which subject we are looking for. If given course ID 67B, we cannot draw information regarding the student as we don't know for which student we are looking for. So, student ID, course ID uniquely identify any row in the data as we have many-to-many relationship. Many-to-many relationship. One student can register for more than one subject by more than one student. The composition of primary key are the student ID and the course ID. The professor column depends on course and not on the student. This is called partial dependency, which should not exist for second normal form. Here is an example. Our objective is to remove professor column from the marks table and to move into the course table. The course name is extracted from the student table and together called course table. This is how second normal form works. Third normal form. The table should be in the second normal form in order to allow for third normal form. It should not have transitive dependency, that is, no column should depend on other columns. Here is an example for violation and solution of third normal form. There are student ID, name, total fee, fee paid, and fee balance in the given table. There are three columns illustrating about the information of fee. The two columns will tell about the other information. So, dropping one column from the above table gives us a solution and allows for the third normal form. Denormalization. Optimization technique in which we add redundant data to one or more tables. This is an approach used on normalized database in order to improve the RAID performance. The advantages of denormalization are minimizing the need for joins, decreased updating errors, and increased consistency. Reducing the number of tables in some cases. Disadvantage. It is an application specific and needs to be re-evaluated if the application changes. This is a slide shows list of references. Thank you for watching my presentation.